I'm Benny D, and in this video we're going to look at how to find the volume of a torus. Okay, so you might be thinking of what shape is a torus. Okay, well, a torus is actually the mathematical name for a donut. Okay, so we can think of it like this, okay, but it's three-dimensional. Okay, it's three-dimensional. Okay, we need to think about how we could find this volume. Right, well, what we can think about is if we cut our torus in half, say, if we cut it in half through there and had a look at the end, we'd actually see that there's a circle in here. Okay, and we know that's going to have a radius, that circle, of, we're going to use little r. Okay, so we know we've got that there, and now we could probably think about this. Okay, if I cut it here, okay, where I've drawn the circle, and bent it out, I'd end up with one big cylinder. Okay, one big cylinder, which makes sense. Okay, so if we think about how we find the volume of a cylinder, our volume was equal to pi r squared, okay, because that's the area of our circle, and remember pi's got that special number 3.14, okay, and our radius squared means it's the radius times the radius. So we had that, okay, for the volume of a cylinder, and we had to times it by, if you like, the length of the cylinder. Okay, so that's where we had this situation going on. Okay, so we had our radius here. Okay, well, I'll say little r still. Our radius here. Okay, and this length. So that gave us, this formula gave us the volume for this. Now in reality, all we're saying is that we're pulling this end around and attaching it to this end. And we're going to get our torus. So we need to think, okay, well, how are we going to work out how we end up getting to the next stage where we get this volume? Okay, and what we think about, okay, is, well, this is a circle. The donut itself is a circle. Okay, and what we do is we look at the distance from the center of our donut, okay, the middle of the hole, okay, to the middle of our outside part of our donut. Or if you like, to this center part of the circle when we cut it in half. So we can go from here, if you like. We look at that radius. We think, well, okay, how far have we stretched it around? Well, how far we stretch it around is this distance through the middle of our donut there. Is really, if you like, with our cylinder, the distance that we've moved the middle of our cylinder around to the middle of our cylinder, it's really taking this path around there. Right? And that path, well, it's a circular path. If we're trying to work out how far around our circle we've gone, well, that's really looking at its circumference. And the circumference of a circle is equal to 2 times pi times the radius of the circle. Now, I'm using big R here because I've used big R in my diagram here. So that's the distance around this circle that we've used, or how far we've bent around our cylinder. So it makes sense then that we need to combine these to get to our actual volume. So instead of our length of our cylinder, we're actually going to substitute in 2 pi big R. Okay, and that's going to be the volume of our torus. So if we had this radius being 4 centimeters and this radius being in here 2 centimeters, then we're going to find that our volume equals pi times our little radius, which is 2 squared, times by 2 times by pi times our big radius, which is 4. So we're going to see that we get 2 times 2 is 4, times 2 is 8, times 4 is 32. So we're going to have 32 times by pi times by pi. Well, if we do remember, pi's got that special value of 3.14 times 3.14. Okay, so times it by 32 by 3 gives us 96. Now extra bit, let's call that around about 100 times our 3.14. So we're going to end up with a volume around about 315 centimeters cubed. Now remember, this is just an estimate. In reality, we would need to actually get our calculator to make sure we're right on this. Okay, but overall, we're looking at around about that. So you don't have to use toruses when we're doing our skate park design, but it's something that you will be able to work on if you like.